All right, so here's a couple examples to help you with the inequality word problem. So today's goal is to be able to solve inequality word problems. These two problems are not on your assignment, but I think with these examples, you'll be able to figure out how to do your assignment. Let's read example number 1. Sal's phone plan charges a monthly $20 flat rate plus $8 per gigabyte for mobile data. How many gigabytes of mobile data can Sal use each month and still keep his bill under $50? And let's go ahead and just make for gigabytes, let's just go ahead and assign a variable. We're going to call this variable G. Okay, so the variable is G. All right, this is a slope problem. If you can remember back to previous word problems, way back in like Unit 1, here's what happens. The phone plan is going to charge a monthly $50 flat rate. So this is the starting point. It's called the y-intercept, the starting value. All right, before Sal even really uses his phone at all, he's got to pay $20 right off the bat. Okay, this is called B. Now this $8 per gigabyte, this is like the growth or the slope. This is how much it goes up for every gigabyte. That's called M. So if you think of MX plus B, all right, Sal's phone plan, the way we're going to write this charge is going to be 8x, or I'm sorry, not 8x. It's going to be $8 times the number of gigabytes, so 8G plus whatever the starting value is, whatever the flat rate is, plus 20. All right, so this is how we turn Sal's monthly bill into a formula. You take 8 times the number of gigabytes plus $20. All right, and the idea is we need to keep his bill under $50. Well, that sounds like a less than problem to me. We've got to keep his bill less than $50. And notice this doesn't say $50 or under. It says under 50, so the 50 is not included. Okay, in Sal's opinion, if it's equal to 50, that's too much. It specifically says keep it under 50, so we are not going to put a bar in this particular problem. All right, but if we solve this inequality, if we subtract 20 from both sides of the inequality, 50 minus 20 is 30, and then we divide both sides by 8, we are going to get a decimal. Let's see, there's always a debate. Should we convert it into a fraction or leave it as a decimal? A lot of times I'll see what the decimal looks like. Oh, and this one comes out pretty cleanly. This one comes out to 3.75. If it's a clean decimal like that, then by all means leave it as a decimal. If it comes out real messy though, your other option is you could write it as a fraction. If you'd rather leave this as a fraction, it comes out to 3 3/4. Okay, the 8 goes into the 30 3 times with 6 left over. It reduces to 3 3/4. But you know what? This one works out great as a decimal. So I'm going to just leave it as a decimal. And this gives us our answer. As long as Sal uses less than 3.75 gigabytes, his phone bill will be under 50. Now let's graph this. Negative 10, 0, 10. Now there's always kind of a debate on the graph. Here's how we're going to write our answer. 3.75 is roughly here. I'm going to use an open circle because the 3.75 is actually too much. If he uses 3.75, it comes out to exactly 50, and that's too much. So he's got to go less than this. He's got to do like 3.74 or 3.73, any amount that's less than 3.75. Now the debate is always, how far should I draw my arrow? Like, is there such a thing as a negative gigabyte? I'm going to go ahead and just tell you, we're just going to go ahead and write an arrow. I know technically there's no such thing as a negative gigabyte that you could use, but just for the purposes of this problem, we're just going to go ahead and draw it as an arrow here. It can be anything under 3.75, but it does not include the 3.75. So listen, I don't know how you would ever get negative 10 gigabytes, but if somehow you could, it would be fine in this particular problem. All right. And it didn't ask for interval notation, so I'm not going to do it. I'm just going to leave it there in the graph. Okay. Example number 2 then. This one's a little trickier. Jill has earned scores of 91, 92, and 85 on her 3 algebra tests. What must she score on her 4th test so that her final average falls in the range of 90% to 93%? Okay, this is, if you're curious, this is actually an A minus. And so Jill just has this goal. I want to get an A minus, okay? I want my final score to end up between a 90 and a 93. What do I have to get on this last test? Well, let's think about averaging 4 test scores. All right, if I had 4 test scores, what I would do is I would add the 4 of them together, and then I would divide by 4. But here's the problem. I know, so this is how you find the average of 4 numbers. You add the 4 numbers together and you divide by 4. Well, I know what the 3 test scores are, but I don't know what the 4th test score is. So this 4th test, let's go ahead and assign it a variable. We'll just call it, I'll call it T for test. So what we're going to do is we're going to put a variable here. I don't know what the 4th test is, but I'm going to give it a variable. I'm just going to call it T. And I know if I add these 4 test scores together and divide by 4, it'll give me her final average grade. Now, she wants her final average grade to be between a 90 and a 93. Guess what? That's a compound inequality. I'm going to put a 90 over here on the left and a 93 over here on the right. And since it's inclusive, I'm going to put the bars here and here. A 90 is okay and a 93 is okay. All right, so now I have to be able to solve this problem. A key to solve this one is, first of all, this is a lot easier if you can get rid of this fraction. And the way you actually get rid of this fraction, this divided by 4, is you're going to multiply this fraction by 4. And this 4 will cancel out this 4. And you're allowed to multiply the middle of this compound inequality by 4 as long as you also do it to the left and you also do it to the right, okay? So 4 times 90 is 360. 4 times 93 is 372. And then, while I'm at it, I'm going to go ahead and add together this 91 plus 92 plus 85. Those all add up. Those 3 test scores add up to 268. So while I'm at it, I'm going to go ahead and add all these together to 268 plus T. Look how much simpler that just became with using those kind of 2 steps. I multiplied everything by 4, and then I combined the 91, 92, 85. So now I need to solve for T. My last step, just subtract the 268 from the middle. And then to balance that out, I also have to subtract it from the left, and I also have to subtract it from the right. All right, 360 minus 268 comes out to 92. All right, and then 372 minus 268, that comes out to 104. So I'm going to tell Jill here, Jill, if you want to reach your ultimate goal of scoring between a 90 to a 93% for your average, then you better get between a 92 and 104 on your test score. Now, you may look at that and say, Mr. Klein, how could you ever get 104% on a test? Well, you never know. There might be some extra credit involved or something like that. So I'm going to do this. I'm going to go like this. I'm going to say 0, 50, 100. Her test score needs to be between a 92 and 104. So here's a 92. 104 would be a little bit kind of out of the range. So here it is on a graph. As long as her 4th test falls between 92 and 104, she's going to hit her ultimate goal, a final average of 90 to 93. There it is. All right, so you have I believe you have 4 problems on your assignment. Use these examples to help you out. Best of luck. Take care.